Rajit, is my screen visible?
Good evening, sir. Yes, sir. Your screen is visible.
Screen is visible, right?
Yes, yes.
Slide is
Yes, sir.
moving. Slide is also moving.
Yes, sir.
Yes, yes.
Okay. জাভেদ, খবর কি তোমার?
গুড ইভিনিং স্যার।
গুড ইভিনিং। হাউ আর ইউ
কেমন
জাভেদ?
আছেন?
ঠিক আছে, চলে যাচ্ছে। তোমার কি খবর?
এই তো স্যার করছি। এখন তো আপাতত বন্ধ আছে ইউনিভার্সিটি, এখন বাড়ি থেকে কাজ করছি। 15 তারিখের পর দেখা যাক কি হয় আবার।
তোমাদের কি ইউনিভার্সিটি থেকে ধরেছে নাকি?
না না, গভর্নমেন্ট নোটিফিকেশন দিয়ে দিয়েছে তো, মানে
না
স্কুল
সেটা জানি, জিজ্ঞেস করছি
হুম।
তোমাদের ইউনিটের মানে কি বলে এর অবস্থা কি?
না ওইখানে কারো হয়নি,
হয়নি?
মানে আমি যতদূর জানি আর কি।
আমাদের তো মানে ডিপার্টমেন্ট পুরো ভরে গেছে, ফ্যাকাল্টি স্টুডেন্ট সব।
এখন
Full.
স্যার সব জায়গায়, ইভেন আমার রিলেটিভদের মধ্যে অনেকে সব
হ্যাঁ, আমারও তো ভাইপোর হয়েছে, ভাগ্নের হয়েছে।
মানে নতুন বছর শুরু হলো এরকম একটা বাজে ব্যাপার নিয়ে।
নতুন বছর এলো নতুন ভ্যারিয়েন্ট নিয়ে।
হ্যাঁ, এখন স্যার টেস্ট করাবে মোটামুটি 70-80% লোক পজিটিভ বেরোবে।
That is true. That is true.
টেস্ট না করা হবে নেগেটিভ, করা হবে পজিটিভ, যে অবস্থা।
That is true. How is the condition in Sri Lanka, Surajit?
Quite better if we compare with India. But don't know in near future what will happen.
I mean, maybe 50% of our faculty members are already affected.
Here we don't have that kind of scenario. We have much better here.
That's good. As long as you can stay better, that's fine.
Right. So, Dr. Maheshi, could you please start?
Am I visible to you?
Yes, you are audible. And now, yes, we can see. Yeah.
Okay. So good evening, everyone. As the chairperson of IEEE Sri Lanka section, I warmly welcome you all to this webinar organized by the IEEE GRSS, which is Geoscience and Remote Sensing Society. The topic for today's talk is machine learning in societal benefits with focus on Earth observation. The event is organized by the IEEE Sri Lanka section, chapter and subsection coordination committee with the ambassador of IEEE GRS, Dr. Surajit Ghosh. And I wish to warmly welcome all the presenters and the moderators for the event. From IEEE GRSS, we have Professor Ashish Ghosh, our keynote speaker today, and Dr. Pratik Dash, Dr. Javed Akhtar, as well as Dr. Surajit Ghosh. The objective of the event is to introduce GRSS activities to the IEEE Sri Lanka section, and then discuss the possibility of forming the IEEE GRSS chapter in Sri Lanka. So for this purpose, Dr. Surajit Ghosh has initiated this discussion, and as we thought, since this is a new section for the Sri Lankan membership, let's start with a small kind of like introduction to this society as well as the activities conducted by that. So to begin with event, let me welcome Professor Ashish Ghosh, who's doing the keynote address today. So Professor Ghosh is a professor in Machine Intelligence Unit, Indian Statistical Institute, Calcutta. He received the BE degree in Electronics and Telecommunication from Jadavpur University, Calcutta in 1987, and the BTech and PhD degrees in Computer Science from Indian Statistical Institute, Calcutta in 1989 as well as and 1993 respectively. Then he received the prestigious and most coveted Young Scientist Award in Engineering Science from the Indian National Science Academy in 1995 and in Computer Science from Indian Science Congress in Science Congress Association in 1992. So his interests include pattern recognition and machine learning, data mining, image analysis, as well as remote sensing, image analysis, soft computing, fuzzy sets and uncertainty analysis, neural network, evolutionary computation, and bioinformatics. It's very vast. So he has already published more than 100 research papers in international reputed journals and referred conferences, and has edited 8 books. Then has acted as a member of the editorial board as the associate editor of various international journals. He served in the capacity of program chair, tutorial chair, plenary speaker, and as a member of a program committee of many international conferences also. So, Professor Ghosh, without further ado, let me welcome you to Sri Lanka section as well as this event. And it's over to you, sir. You can start. Thank you, sir.
Thank you. Thank you so much, Maheshi. And thank you, Shurajit, for taking this good initiative to spread the activities of GRSS in Sri Lanka as an ambassador. So we hope in due course you will have more members and you can have a full chapter in Sri Lanka itself. Okay, so to spread the activities, Shurajit has taken a big initiative to start this with a very small gathering or kind of workshop or seminar or whatever you say. And I was asked to give a brief discussion, a talk on machine learning for remotely sensed data analysis. So maybe in roughly 40 minutes or 45 minutes, I will be trying to tell you about what is learning, what is machine learning, what are the different types of learning present, and then how do we apply this sort of learnings for some aspects of remotely sensed data analysis. So maybe you are aware, or maybe in due course you will be understanding that yes, remote sensing is a very popular topic. Almost all fields actually deal with this sort of data coming from remote sensing. So what is remote sensing? Usually any data that comes from a sensor, which is where you are not touching the object, is by in theory is a kind of remote sensing. So the data that is coming from satellites, the data coming from drones, coming from aircrafts, or even helicopters, or some such devices, is usually a kind of remote sensing data and comes from the field. So we can use various types of platforms. We can use various types of sensors to get data. Maybe from different perspective or different aspects of spectrum, EM spectrum, maybe kind of optical range, maybe infrared range, maybe non-optical range, and wherever it is. So depending on the type of the platform or depending on the type of the sensor we use, we get different kinds of data. Basically, data coming from the Earth. So basically, let's say we have a satellite. We are taking pictures from a long distance. So what are we getting? As Earth's surface. We have drones. We want to monitor the cultivation fields. We are using drones, or you are using helicopters, or you are using some other remote sensing device to get data. So depending upon the platform that we are using, depending upon the type of sensor that we are using, we will be getting data from different with a different kinds of resolutions, maybe with respect to time, with respect to space, with respect to other parameters. So how do we actually analyze this data? This data is what is called EO data or Earth observation data. We want to observe the Earth from this data. Say, for example, we want to see what sort of cultivation is going on. We want to check the kind of vegetation. We want to check whether there is some habitation in some place or not. In fact, if you look at different parts of India or Sri Lanka, you will see that many parts, so many private initiatives are taken for academic institutions. There are big vegetation fields, and they are now converted into habitation. They are converted into concrete structures. This is a kind of change. So can we monitor this? Can we observe this Earth data through various kinds of sensors? Maybe satellite, maybe space shuttle, maybe airborne helicopter, maybe some UAV, some UAV or drone or aerial television or aerial photography, many sensors, many ways we can get the data. How do we analyze this data? There can be plenty of tools, plenty of techniques for analyzing this data. I'll just try to tell you only one aspect of that, how to analyze this data from a perspective or is a machine learning perspective. So let's say this first image is from agriculture, then we have forest, then we have some kind of soil, some water bodies, land use and land cover, maybe some other things like environmental monitoring, oceanography, disaster management. If I look at, there will be plenty of applications. So how can we actually use this remotely sensed data for observation of Earth or for human being or human mankind? More specifically, what I will be trying to tell you is how do we actually use this data, or we manage this data, or we get information from this data, extract information out of this data using some machine learning tools. Say, for example, on the left-hand side, if you see this image, there was something like a forest. And in the right side, you will see that a part is already damaged by fire. Some forest fire occurred. These red portions on the right side. And this portion is already burnt. There was some kind of vegetation over here or forest. Now it is burnt. So how much damage it is? What portion of this area is actually affected by this? This sort of analysis we want to do using some tools or techniques coming from different perspective or different aspects of machine learning. We want to observe agricultural fields. So what part is, where are you cultivating paddy? Where are you cultivating other crops, say mustard or some others like oats or whatever it is? Can we do that? Can we predict the yield? Can we use that? Okay, maybe whether we need to do a kind of weed removal, or we need to give some manure, or we need to check whether the paddy is already ripe or not. Can we monitor this? Yes, maybe using different kinds of machine learning tools and data of this sort of remote sensing devices, we can handle this. So for that, what we need is what is machine learning. One aspect of machine learning, or one aspect of data analysis is by using machine learning. So let me first give you a rough idea as to what is machine learning. And then before that, what is learning? How do we learn? What does learning mean in human being? Acquisition of knowledge or skill through some study, experience, or being taught. That's what is called learning. We acquire knowledge through our skill. We acquire knowledge through certain studies. We acquire knowledge through our experience, or we are being taught. If we remember our childhood days, we remember that my parents or our parents usually teach us, okay, this is how a tomato looks like, so this is how an orange looks like, and other things. So that was actually we are being taught and we learned it. So this is one of the very intelligent characteristics or intelligent activities of human being. Right? So can we really apply this learning technique that we observe in human being in a machine so that the machine can also learn something? So what will the machine learn? With respect to this Earth data, with respect to the application of EO data, machine learning will have plenty of them. What will it learn? Maybe from the pattern, it will tell us, okay, this is the pattern of a paddy field. This is the pattern of a wheat field. This is the pattern of a paddy when it is ripe. This is the pattern of rice paddy when it is not ripe. So these patterns need to be learned. The way we learn, can we imitate that with the help of a machine, with the help of automatic system, with the help of some intelligent activities that needs to be performed by a machine? So this is nothing but finding out a kind of statistical regularities or relevant features or relevant patterns from the data. Like if it is vegetation, what signatures does it have? But if it is a concrete structure, what features does it have? So this is what needs to be learned via a machine. Okay. So learning is nothing but a key hallmark of intelligence, the ability of an agent or a machine to take a real data, take certain feedbacks about this, and updates its parameters so that its performance is improved over time. This is one of the very important characteristics of machine. The performance should improve with time. Now you are teaching somebody and the performance of that person is not at all improving. Then practically there is not much learning. So the system that we will be designing, so the machine learning system that we will be designing should improve its performance with passage of time. So today, if the accuracy of prediction is on say 60%, in due course with more learning, the accuracy should increase. If it remains at 60% all the time, then probably the system is not learning. And this is where a machine learning system will differ from all other standard computer programs. Very standard classical example of spam filtering. We see that our mails that is coming to the Gmail is divided into multiple groups. Spam, non-spam, social, maybe updates and other things. So what are these? Basically, initially somebody taught the machine, okay, if it is coming from this sort of places, this is a spam message. If it is coming from this sort of places, it's a kind of normal message. If it is for advertisement, then it should go to this folder. So these are the different classes or categories into which initially somebody taught the machine. So that part is what is called the training part. So initial part is giving some training to the machine that, okay, this is how you have to classify this. And then in due course, with passage of time, the machine will learn how to do this. Say, a machine has to understand and recognize handwritten characters for postal code recognition. How does it do? Initially, human being will tell the machine, okay, this is how a 1 looks like. This is how a 2 looks like. This is how a 3 looks like. These are the characteristics of a 4. So those characteristics or features or regularities are actually being learned by the machine. So this first phase is what is called training phase or learning phase. Second phase is the testing phase. For the training phase, we need a kind of human annotated data. So this Earth observation data, if we want to train the machine, if we want to train the system, initially we will have to have a kind of annotated data, which will tell us, okay, this is how a paddy looks like. These are the signatures of a paddy. Looks like means it will be represented by spectral signatures. Like this is the reflectance value for paddy field. This is the reflectance value of wheat field. This is the reflectance value of some wheats. So those are the things that would be given by human being initially. And that part is what is called the training data. That has to be learned by a machine. And in future, the machine will predict for an unknown. Example, if a new thing comes, then the machine will tell, okay, this is either a paddy or a wheat or something else. So machine learning is programming computers to optimize a performance criteria using example data or past experience. We are programming the computers to optimize some objectives with certain characteristics using previous examples or that annotated data or what is called training sample and from the past experience. From the past experience, machine will learn. So this is how our machine learning system works. Initially, there will be something annotated. Initially, some training would be given. And from the training set, the machine will extract the statistical properties or characteristics. And why should we use it? Because always doing the same thing by human being is very difficult. Human being commit errors. Human being does not like to work for a long time. Human being cannot work in odd environments. So machines will have certain characteristics or good characteristics. It tirelessly works. It works with big data sets, which human being cannot do. So if we want to distinguish a standard program or software from a standard machine learning program, then this is the slide. So for standard program, what do we have? We have the program and we have the data, the machine gives you the output. But for machine learning program, you have the data and you give some output, and these two together updates the system. Updates the parameter of the system to have a good hypothesis. What is the hypothesis? Hypothesis is something like, okay, if the feature value is this much, if the spectral signature is this much, if its color is this, then it is a paddy field. So this sort of hypothesis this machine makes. So for standard computer programming, what you have X, you have the functional value of the function effects, and what you get is the output effects. For machine learning programs, what you have is X and the corresponding Y for an initial set of data. And your job is to estimate the function F. So what we get is F dash X and F estimate of X. So traditional program gives you the output. Machine learning program actually gives you the estimate of the hypothesis. So this is where is the fundamental or conceptual difference of machine learning program from other programs. Without machine learning, very specific instruction. Say I want to sort 10,000 numbers. I give the data and I give the program, machine sorts it. I don't need machine learning for that. I don't need to update the parameter. All the time the result is fixed. But for machine learning, when we have certain data and we expect that there are certain rules, we expect that there are certain regularities. To extract that rule, to extract that regularity, we need a machine learning program. So we have the data. From the data, we try to extract certain rules. So that is what is machine learning program. Conceptually, this is where you differ. You can look at this animation. You will see that what portion or which part is actually learning. Like say, this is a machine. The machine has been taught something. And this lady is trying to check whether the machine has learned some characteristics or not. Right? So she is asking certain questions and the machine is giving answers. We look at this animation. She's not asking certain questions and the machine will give answers. So the lady is sending a picture and is asking this machine whether the machine can answer certain questions, certain set of questions. Like this image is set. And maybe this is a an image taken by a helicopter or maybe by some other camera or UAV or whatever it is. And the lady is asking, what do you see? The machine answers, yes, I can see two human beings. Anything more? Maybe the answer comes that yes, I can see something else. Yes, it says 5 more trees. Anything else? Besides the dog. So it can see a human being, the trees, and the dogs. So up to this much, their machine had learned. Machine had learned from its previous experience, previous knowledge. Now, can you tell me what is the person in the red box is doing? It's a difficult question. Machine answers no. This means the machine learned something, but may not be the full thing. Maybe another question, and the machine says, no, I cannot. So that means the learning of the system is not complete. Updating of the parameters is not perfect. The hypothesis that the machine has made is not proper, not 100% accurate. So what does this lady do? She sends some more images. So this is the data, new data the machine is giving, this human annotator is giving to the machine, and the machine is updating its learning. So then you say something is going on inside the brain. So this means that the machine is learning, the machine is updating. So this portion is learning, this upgradation of the system, the upgradation of the parameter of the machine, upgradation of the parameters, so that the hypothesis becomes more accurate, and that part is learning. Now, if the lady asks the similar set of questions, it's likely that the machine will be in a position to answer those questions which initially it could not answer. So this part is actually the machine learning part. That yes, with more data, the machine updated its system. The machine modified its program or the parameters such that the accuracy enhances. So this is why I said that there has to be improvement in performance. So the performance of this machine will be improved. So this is what is called machine learning. Now you will say that this machine is in a position to answer more questions. So this shows that the training data is very important. Training the system is very important. Proper training has to be there so as to have proper accuracy. So whatever machine learning algorithm we will be designing for your data analysis should have a good set of training. Good training, proper training has to be there. Okay, now you will see that the machine is answering almost all these questions properly. So you see the person is walking. So more answer, better answer than the previous. Maybe it will give you some more answer. How about the person in the blue box? Maybe the machine gives you correct answer. So I can presume or I can say that yes, the machine has learned something more. So maybe it has not learned 100%. Maybe whether the person is male or female, the machine fails to answer. So that shows much more training would be needed. Now, how will you check whether the machine has learned properly or not? You have to check by passing certain questions. And if you see that the machine and a human being, they are almost indistinguishable, then you can claim that yes, the machine has learned. Almost indistinguishable. Same set of questions are asked to a machine and a human being. If you cannot distinguish whether the other part which is giving you answer is a machine or a human being, then you can say that yes, the machine has learned. So what is machine learning? The field of study that gives computers the ability to learn without being explicitly programmed. Sorting is an explicit programming. In machine learning, you do not do that explicit. You train the system and the system automatically upgrades. Okay. So machine learning is about designing algorithm that allows the computers to learn from previous experience or previous data. So if you have a lot of data, if you have a certain understanding that yes, certain rules exist inside that data, but you do not know that rule. But you expect that there are certain kinds of statistical regularities in that data. You expect that all trees will have certain kinds of features. You expect that weeds will have similar characteristics. You expect that water bodies will have a certain kinds of attribute values, and it can be different from the attributes of the concretes. So what are these attributes? That can be determined using machine. So we learn or extract rules from data. So if you have certain amount of data or big amount of data from where you are interested to extract certain rules, you go for certain machine. Otherwise, for sorting, searching, or finding out the derivative of a function, you don't need machine. So how will you check whether the machine is learning? It's not that the accuracy has to be improved always. It can expand its horizon. It can do more jobs. It can do the job faster, or it can enhance its accuracy. So these are the three more popular measures, but are not an exhaustive list. So somewhere some improvement has to be there. Either you can do it better, or you can do it faster, or you can do it more accurately. Anyway, if there is an improvement like this, then possibly we will say that yes, the machine is learning, either with respect to accuracy, or with respect to the solution correctness, or with respect to the solution quality, or the speed of performance. In any respect, if it improves, then you can say you have designed a better algorithm for learning. And this is all that is going on inside a machine learning. That is, we have various kinds of data, maybe your data, maybe financial data, maybe scientific data, whatever may be the data. From that data, how can we discover rules more accurately with proper correction and proper solution quality and fast? So that's all about machine learning. Now, there will be certain questions. Why do you study machine learning nowadays? Why did it suddenly become popular? Because of many facts and mostly three different issues. Now we have plenty of data to train the system. Also, we have good, powerful machines, maybe GPU servers and other things, which can crunch this data very fast. And we have a few good algorithms also. So given these three extra characteristics or extra features, we now see that there is a big boom of machine learning. Many basic effective algorithms are available. Large amount of online data is available. And a large amount of computational resources also available. So if you look at in this perspective, then basically AI is a bigger field where we try to simulate human being with all the intelligent activities. And a subpart where this learning part will be involved is machine learning. And nowadays, deep learning is becoming more popular. Deep learning is a specific type of machine learning where multiple layers of artificial neural networks are actually being used for learning. I can learn using various tools and various techniques, but if I do that using only artificial neural networks with many layers, then we'll say that is deep learning. So AI is the biggest umbrella. Under this umbrella, we can have symbolic AI or learning-based AI. So this right part is learning-based AI, which is machine learning. And under machine learning, we'll have deep learning, which is nothing but a subset where you deal with neural network-based learning only. Okay, so for machine learning, this data, whatever data you have got, you will be actually dividing into three parts. There will be some data which will be used for training the system. There will be some data which you will use for validation of the system. And finally, there will be some test data. So whatever data you are collecting, divide into three parts. One part is used for training. And this training part is actually what you need to annotate. You have to have an expert which will tell you, okay, this is the input, this is the corresponding output, this is the input, corresponding output. Similarly, for the validation part also. That you should know what is the input and the corresponding output so that you can validate whether the system has learned properly or not. The system is trained properly or not. But for testing, no. You get some unknown data and the machine predicts. So be careful that whenever you are going to apply some machine learning tool, you have to have a good set of training data and a validation data to train the system properly. And for this, you need human annotated data, or what we call level data. So field expert and domain experts are needed for this particular purpose. And testing is what we actually do. Now, based on the type of available data, there are 4 types of popular learning, usually a supervised one. So whatever I was discussing, this training data and other thing, that's a kind of supervised learning. Unsupervised learning is something where you really do not have this sort of labeled data where you know the input and the output. From the unlabeled data, all the data, you try to find out statistical regularities, similar characteristics, similar features. So that's kind of unsupervised, without the help of a supervisor. Semi-supervised is somewhere in between, where you have only a small number of known samples. Known means input and output known, and you have plenty of unknown. But the known samples are not sufficient enough to train your system. So you have to train it and use the rest unlabeled data for doing this. So you do is what is called semi-supervised. So 3 most popular types: supervised, unsupervised, semi-supervised. There is one more, reinforcement, where actually there is a kind of learning, but that's not really supervised. There is a critic. The critic tells you whether the output is right or wrong, but does not tell you what is the actual output. So it just analyzes and says, okay, the output is not correct. Output is close. Output is not marked. The problem is you cannot find out how much mistake you have made. If the critic would tell you this is the output, this is how far you are, then life would have been simpler, and that is what is supervised. But the critic does not tell you what is the outcome. Critic says, oh, you are very close. So it forces you to learn. So that's a kind of reinforcement. So these are the 4 major types of learning actually being used for machine learning applications to remotely sensed data or whatever data we are talking about. Supervised, where you have plenty of level data, training data. Unsupervised, where you really do not have some good training data, not at all training data, you have only unlabeled data. Then you have a kind of semi-supervised, where you have a small number of training data and plenty of unlabeled data. And the other one is a little different, where you have a kind of reinforcing, somebody is forcing you to learn this. Now you look at this. So left-hand side, these are the training patterns. Okay, through this pattern, you learn the system. Now, what does it learn? The system learns that, okay, this is one group, it's a kind of land. You see, all of them have common characteristics, land features. So they have some water bodies. All these are kind of water bodies. So there is a learner and a supervisor and a teacher. So this learner is the machine and supervisor is the annotated data. And this annotated data, all of them are basically water bodies. Right hand side, all of these are land covers. So the machine learns. And if there is an unknown sample like this in the bottom side, the machine says that, okay, this is a kind of land cover on the left hand side, and the right hand side is a kind of water bodies. Why? The characteristics or features of the image on the left hand side matches with that of the features of the land cover. So that's what is the use. So the first part was training with these given samples, and then the second part was the testing using these 2 or any other new sample comes. What the machine will do? The machine will try to match with the initial data set that it learned. But if it is unsupervised, nobody told the machine initially that, okay, these are water bodies or these are land covers. What machine is doing is trying to see which of these are very similar. If you look at, you'll see that all these images, these left-hand side images, they are very similar. Almost blue, 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 blue. But here, green and other things. So this statistical regularity, the machine is trying to find out, and that's what is called unsupervised. The machine tries to find out a set of characteristics which is present among some of these data. So a set of data which are similar in nature will be put into one group. Now you will say that yes, paddy fields, all the paddy fields look alike. All the jute fields, they look alike. So these are nothing but clusters. So we can form clusters or group the data using a kind of unsupervised learning cluster. So basically patterns or points which are very similar, they will be put in one group. Like you look at. These are green trees, these are dry trees. So this will be one cluster, this will be another cluster. Nobody told the machine. The machine tried to find out what are the similarities between these. So these three are similar, these two are similar. So similarity the machine found out. But now you can ask whether why not all of them trees? Yes, you can say trees. So clustering is usually a bit difficult and a bit subjective. But supervised learning or classification, that was kind of easy. Semi-supervised learning is very popular in case of something like a change detection. So fire destroyed a part of the forest. So initially you did not know how does a burnt tree look like, or there are very few samples. So you train the system with these few samples of burnt trees and plenty of unlabeled samples and new data, and then use that for this kind of forest fire assessment, damage assessment, or kind of disaster management, flood management. So semi-supervised learning is very popular in case of this sort of management. So we can use supervised, we can use unsupervised, we can use semi-supervised, different modes of learning for analyzing remote research data. Okay. Now, why should we use both labeled and unlabeled data? Because of the fact that unlabeled data is plenty and labeled data is costly. We cannot always get labeled data. So unlabeled data is very costly. Unlabeled data is cheap. Labeled data is very costly. So rather than always trying to find out all labeled data, we can go for something like unlabeled data also. So both labeled and unlabeled data we should use. So if we want to use this sort of machine learning tools for Earth observatory data analysis, we will require a large amount of memory because the data size is very big. So we will need big machines, powerful machines. We will require large training data. We will have generalization issues, and we will have plenty of parameters to be optimized. So if you are going to use some such systems, you need to be careful about this, that you need a big powerful machine, you need a lot of data, you need some generalization issues, and the different types of parameters that you need to optimize. So depending on this sort of need analysis, various kinds of machine learning tools are in existence, different types of classifiers like k-nearest neighbor, then box classifier, fuzzy classifier, the minimum distance classifier, then learning-based classifier, neural network, CNN, recurrent neural network, support vector machine, rule-based classifier, decision trees, random forest, many. Plenty of tools are designed and plenty of machine learning algorithms are designed based on the similar characteristics, and one differs from the other with respect to their performance and with respect to their requirements. Some of them are very easy to implement, some of them are difficult to implement, some of them require more training data, some of them require less training data. So depending on the type of the data that you have, you can use some of the techniques. Depending on the mesh capacity of the machine that you have, depending on the training patterns you have or label data you have, you can go for these different types of classification and clustering tools, supervised and unsupervised tools. Right. So for example, if I want to use a land use or land cover classification, I can go some types of classifier like SVM, or a classifier like minimum distance classifier or k-nearest neighbor classifier. But if I need to do a kind of change detection, then possibly I will be using kind of semi-supervised classification or a kind of neural network based classification where you get the training samples part by part. Right, so land cover classification is like classifying into forest, classifying into different sand or built up area or cultivation land or water land. So these are the different types of land cover. So what we'll have is a kind of 5+ classification. So I can use k-nearest neighbor classification, I can use SPM or some other things. Initially, there will be some training patterns to train the system, and then finally, I will use some other data for prediction. So I want to find out the building footprints, right? So building footprints will have certain features. So that can be predicted. All these red marks are predicted as building footprints, one class. Building. We are not we are not putting the label for other classes. So like here, we are finding out the roads from an Earth data, observatory data. All the roads are concrete structures, so they will have similar patterns or similar characteristics. Only one class, road class. So you can classify that. Maybe water bodies, and then many other things. For change detection, as I am repeating, change detection, we usually do not have plenty of label data, so we can go for something like semi-supervised learning. Right? Say vegetation classification map. You can use it. Different classes, different classifiers. So which classifier will be used for which purpose? This needs to be determined depending on the type of the problem you have in hand, depending on the data you have, depending upon the number of training patterns you have, depending upon the domain knowledge you have. Not only this observation data or satellite data, different kinds of pollution control or prediction of pollution level, how much carbon dioxide concentration is there. We can use some sensors and then analyze this. So prediction of pollution in different cities could be another application. Nowadays, this IoT concept where people are putting different sensors at different places of the city and trying to predict what is the pollution level. It's becoming very popular nowadays. Industrial emission. How much is the carbon dioxide? How much is the sulfur dioxide prediction? Disaster management. Say, if there is any flood, if there is any tsunami, there is drought. So different types of kind of classes or analysis could be done from the Earth data. I'm just mentioning a few names. Earthquake prediction, seismographic data analysis, flood prediction, again a kind of change detection. Forest fire prediction is a kind of change detection. Earthquake, yes, it's a kind of change detection. Where is the damage? How much is the damage? If there is a tsunami, maybe a part of the habitation is gone. So different kinds of disaster management or other jobs we can do. So maybe through forest fire analysis, we can predict what are the risky zones. So this portion is already in fire, so maybe in the neighborhood there will be risky. So different purposes we can use. We can use for landslide prediction. We can use for rainfall prediction. Very popular nowadays, rainfall prediction. Short-term rainfall prediction, long-term prediction. So what type of data we will be using depends upon the availability of the sensors and depends upon the techniques that you are going to use. It could be infrared, it could be what is called optical data, it could be kind of LiDAR data, it could be solar data, then radar data, many various kinds of data is there. But the basic principle of machine learning remains same. All sorts of And drought prediction. You can predict it. Agriculture monitoring, when this is where I have started. So this way, if you go on, you will see that you have thousands of applications, not 1, 2, 3. Machine learning will have plenty of applications in almost all fields of EO data analysis and for remotely sensed data analysis. Maybe for land cover, maybe for finding out the minerals, maybe for checking whether there is tsunami, maybe for checking whether there is forest fire, maybe for pollution level prediction, maybe for rainfall prediction, and whatever it is. And nowadays you will see that almost all fields are trying to use a kind of deep learning tools. That has become very popular because so many packages are available. So maybe I will stop here. I just try to give you a rough idea about what is learning, what does learning mean, what does machine learning do, and how can machine learning tools be used for certain tasks of kind of remotely sensed data analysis without going into the intricate details of each and every algorithm. This is just a glimpse of the application areas of machine learning. Practically, there are thousands of applications of machine learning. In fact, almost all areas, starting from financial market prediction to social media analysis to Earth observation data analysis to satellite remote sensing data analysis to economics to mathematical, mathematical analysis or to scientific data analysis. Anywhere and everywhere you will see machine learning is having its application. Maybe I will stop here. Thank you. Thank you so much. Thank you, Shirojit and and other management members for giving me this opportunity to share my idea and machine learning and its application to remotely sensed data analysis. Thank you. Thank you so much.
Thank you, Professor Ghosh, for sharing your knowledge, expertise, knowledge, and very informative. I think participants have learned something. It has enlightened our knowledge. As we have limited time, so a small question to you: what should be the learning path for the students who are in MSc in geoinformatics or learning remote sensing GIS, but not from the programming background? So how they can acquire this technique? What should be their learning path?
Yeah. So nowadays, you might be aware that there are plenty of packages available. Plenty of packages. For example, there is standard programming language like Python, has inbuilt packages. Say something like R, statistical data analysis package R, or maybe MATLAB, or many other some such application tools are nowadays available. So the students who really do not have a strong background of computer programming, they can start using these packages first. Then in due course, they are MSc student names, so they have sufficient knowledge about logic. So their mathematical ability or analytical ability is quite clear. So in due course, they may get into some parts of this programming that, okay, this is how the logic is put. Then possibly in due course, they will pick up that also. So they can start from using the packages first. That will make their life very simple. So this would be an advice for the students who really do not have a strong background of computer programming. Let them start using the packages in their domain. They are domain experts, so domain knowledge they will be having, and they can predict, okay, what should be the output for this particular data, and if that output is perfect, then they will be happy. If not, then they can start getting into the details. So they can open that black box. Okay, what was the problem with this? And having a logical sense very clear, they will be, programming is not that difficult. They will be in a position to understand the small loops. I'm pretty sure of that. Hope that helps.
Thank you, sir. Thank you for the lecture. So now I'm requesting Dr. Javed Akhtar to discuss on GRAS activities and membership opportunities. Dr. Akhtar.
Is my screen visible?
Yes. Yes, visible.
Okay. First, I would like to thank Dr. Shivajit Ghosh and his uh, associates to take this initiative for the popularization of GISS in Sri Lanka. I would also like to thank Professor Ashish Ghosh for his wonderful lecture on applications on machine learning in Earth data or remotely sensed data. So I would share some quick information about the GISS memberships and its aims and objectives. So first, I'd like to tell about ITPV. It is a Institute of Electrical and Electronics Engineers. It is world's largest professional association, which is dedicated for the advancement of technological innovation and excellence for the benefit of humanity. ITPV and its various members, they inspire a global community through their highly cited publications, conferences, various outreach activities, technology standards, and GRSS is Geoscience and Remote Sensing Society is one of the chapter of ITPV. And in our part of the country, which is in the eastern part, the first GRSS chapter of this part was the Kolkata GRSS chapter, and on a whole, it was the second GRSS chapter in India. It was formed on September 19, 2012. And this GRSS Kolkata chapter, I am coming to this little bit later. So first, I would like to tell you why you should choose the GRSS community, especially if you are from the if you are working in the art data domain or with remote sensing or climate science. You should join this community to gain a number of benefits, like you can gain visibility and access to international programs and research opportunities. You can even connect to the industry as a market for your remote sensing ideas and as a also potential employer. You can get the benefit from a broad spectrum of interest of GRSS members. Right. There will be a lot of different topics which can interest GRSS members. You can network with others. This is one of the main target, networking. It is one of the most important thing in any research domain or any industry domain, networking. And you can work with the like-minded researchers and developers, and you can develop relationships with the world leaders in remote sensing, and you can get benefit from the various both theoretical approach and practical approach in remote sensing. So what can you GISS do for you? They can support your education. They can help you to find and hire talented and motivated people in case you are an employer. They can promote your skills and products, and they can, most importantly, they can aware the research and academic communities about your topics of interest. Maybe it is research related or some product related things. So how can you become a GRSS member? So this membership is open to professionals and students. Member and senior member grades recognize those who have achieved professional proficiency, like uh, degrees, some high quality degrees, or they have some work experience. And fellow grade, another grade, is reserved for those senior members with unusual distinction in their profession, and is conferred only by the invitation of the ITP Board of Directors. So basically, there are three type of membership. Full membership, it is available to those professionals who have demonstrated their competence in ITP field. And there is a sub part of this full membership for the students. They can actually get a 50% discount, and they will get the same benefits but at 50% discount. Uh, any registered student in undergraduate, graduate, or research area, they can enroll a student member. And another is senior member. This is the actually highest grade for IPPV or GSS members. They can self-nominate or can be nominated by others for the senior member grade. I am saying details about it. So this is the procedure of senior membership, that they can, as I said, self-nominate or can be nominated. But before applying for this, he or she must join ITPV and then submit the senior member application form. And this ITPV membership number is required, and there is no additional fee for applying senior member grade. What are the benefits? They receive a plaque, a $25 certificate, and eligibility for fellow grade nomination, and many other benefits. And what are the criteria for senior member grade? A candidate shall be an engineer, scientist, educator, technical executive, or in any ITP designated fields. They should have been in professional practice for more than 10 years, and they should have shown significant performance in their field at least for the last 5 years of their day. And they must supply references from three uh, ITPV members who hold the grade of fellow, senior member, or honorary member. And another third option is affiliated membership, who seek to affiliate themselves with GRSS but do not seek ITPV membership. So they also enjoy the full benefits of this society, including monthly and online access to their TGRSS, which is a quarterly e-newsletter, and reduced conference fee. So I am just showing their page here. You can just go to like this website, grssitp.org, and after that you choose join GRSS. Then you can select whether you can want to take ITPV member or just only GRSS member. And there are also two options. One is preferred option and one is essential option. They are almost similar, but essential and is in essential, they only provide the things in online, all the materials, other things in online, no printed version is provided. But in preferred, you will get the printed version also. So preferred version is little bit slightly costly than essential version. So if you have tight budget, you can go for the essential package. So here is the actually difference. In preferred package, you also get the printed option. And after you choosing your items, you just add in the cart, and then you can automatically go to the payment page like this. And when to join GISs? Actually, it is better to join as soon as possible, because as delay it is yearly membership. So if you delay, the tenure of membership will automatically reduce. So if you suppose get a membership at June, it will valid for only 6 months. Then you have to renew again. So it is better, I recommend, if you are interested to join GRSS, take this as soon as possible. In January, it will be better. Actually, the best window is from September to December. In that case, people get some extra months benefit in addition to 1 year. But still, January is better than taking it later, because validity will reduce if you do the things late. Now, as this GIS chapter is just opening in Sri Lanka, I want to just show you some activities from a renowned GIS chapter from Kolkata, which is one of the most active GIS chapter in India. So, yeah, here you can get an idea what can be done in your chapter. Also, you can get a brief idea about it. So this ITPV in GIS Kolkata chapter, as I mentioned, it was established in 2012. So it basically covers 30 provinces of India in the eastern and northeastern part. They are very proactive in reaching out to different parts through lectures, distinguished lectures, organizing workshop, conferences, and seminars. They also organize international school workshop through the ChapNet program. And there is also student community under this GIS Kolkata chapter, 2 at Kolkata and 1 at Sikkim. These student chapters also organize different lectures, seminars to benefit the student community. And I will just briefly say the activities, what type of activities has been done by this type of chapter, Kolkata chapter. So they have organized 5 workshops in 2021. One day workshop on remotely sensed data analysis on March 13. Then NVIDIA deep learning certification workshop on April 15. Then ITPV workshop on spatial geoinformatics using machine learning approaches on September 20 to 25. Then it was in collaboration with GIS Bombay chapter. Then 3 days Indo-US online workshop on recent advances in AI and ML or climate sciences. So in that particular workshop, I was one of the coordinators. It was done in collaboration of Technology Innovation Hub of Indian Statistical Institute, Kolkata. Professor Ashish Ghosh was also involved there. It was held during November 13 to 15. And in December, there was another workshop on trends in remote sensing and geoscience research, which was done in association with Department of Computer Applications, Sikkim University. Also, they have organized 4 distinguished lectures in various periods of the year. 2 outreach activities were there. And there was a PG thesis competition for women. There was a GIS talkathon, which was first of that kind. organized by GISS Kolkata. There was a mini Olympiad and also some program like a professional development program to celebrate the ITP Day during the first week of October. Also, there has been 2 GISS talk on discussion session from publication on December 3 and 14, and the annual general meeting was held on December 27. So this was the some activities of GISS Kolkata. So the Sri Lanka chapter can get an idea, not necessarily they have to replicate this, but they can get an idea what can be done. And I would like to introduce Professor Sushmita Ghosh, who is the chairman of this ITP GISS Kolkata chapter, who is a professor in the Department of Computer Science and Engineering of Jadavpur University in Kolkata. I would also request others to contact Professor Ghosh if they have any further queries. And also I request Professor Ghosh to tell something more regarding this. Thank you. I'd like to request Sushmita Ghosh Madam to tell something.
Thank you, Javed. I think Madam is not there, so we can.
Yes, I am here, but
Okay, thank you.
yeah, Javed.
Yes, madam.
Hello.
Yes, madam.
Yeah, please.
Yeah, you are audible.
Yeah, but then what am I and what should I say, Javed?
Just your thoughts on.
Okay. Very good evening, everybody. It's nice that you all are here, and and probably I'm not sure about your background as well, but I have understood that some of you are not from machine learning background, but it's not a problem. There are different machine learning tools, softwares which are available nowadays, and if you can just go through some of the tutorials or websites or something like that, probably you would be able to grasp it. And another point is that these GRSs is basically, we have lot of applications, as Professor Ghosh also has shown you, that GRSs has lot of applications, starting from agriculture, transportation, traffic management, minerals, then to health analysis also, healthcare analysis also, and in other areas as well, land use development, etc., etc. So nowadays it is this area is becoming popular for research topic as well. So I hope that in due course, Sri Lanka will also be will also have some footprint in GRSS domain, and we can have further collaborations also if you feel like. I'm a Professor Sushmita Ghosh, professor from Jadavpur University, and I'm from Computer Science and Engineering Department, and my research area is also machine learning, artificial intelligence, and particularly I do work also on image processing, pattern recognition, so with a special emphasis on geoscience and remote sensing. And then basically, if you feel like we can also jointly collaborate, jointly organize some workshops, conferences as well as if you feel that we could be a collaborator for projects or some research, I will be happy to do it. And along with my, our members will be happy to collaborate with you all. Thank you. Wish you all the best. Thank you so much.
Thank you, madam. It's really a great start for us because initially started with excellent lecture from Dr. Ashish Ghosh, and then we can able to understand that what GRS is actually, and you have a excellently have told about the collaboration part as well as the whatever we can go and what kind of background and what kind of motivation is required. So that is very I guess that is very good point to start. And in the participant list we have many people around the world, though most of them are from Sri Lanka. So what I can request all of you that yes, this is a good day to start, I can say, and with this motivation, we can call for the GRSS Sri Lanka chapter. Right now, we are few people, we are few members are already here, but it is more
Yes, I
people are
noticed
welcome.
that one is from Indonesia as well. He has greeted everybody who have participated here. And may I know his name, please? I noticed one message in the chat box. Greetings from IEEE GRSS AES Joint Chapter Indonesia.
Yes, madam. Yes, madam. I think there are few people from various part of the world.
Yes.
And also we are going to form this GIS chapter, and we'll obviously need some support, suggestion and cooperation from Kolkata chapter. And with this I would like to ask and request whoever participant from Sri Lanka, please come forward, and you can contact me or as well as Professor Maheshi or anyone from IEEE executive committee. Please come forward and be a member, so we can form a chapter and we can form the executive committee to run the GRSS activity in the country. So as we are very short of time, and we had started with our lecture on, I can't say this is a lecture, this is a, I can say learning materials, and as well as the motivation as well as the pathway all together. I will show a few examples in next 10 minutes, I can say, that what kind of application we can do using of those kind of machine learning techniques in the field of remote sensing data and all this. So hope my screen is visible to all of you.
Yes,
So whenever
yes.
we are talking, thank you, madam. Whenever we are talking about this Earth observation data, there are various type of data sets are available at different spatial and spectral resolution, and those data sets are taken from various platforms. So in terms of variety, we have platform variation, we have spatial resolution, we have a spectral resolution variation, and as well as we have a different number of bands also are there in different sensors. So who are from the remote sensing community, they can easily catch those terminology, but who are new, they can just follow, and in later phase we can understand that what kind of application we can develop using this kind of characteristics from the sensors. So let's say this is a simple example where we can see on the left hand side the coarse resolution data. When our resolution improve, we can see others features very prominently, and when we go furthermore, we can get much more detailing. So this kind of detailing features can be useful for machine learning purposes. But when you see all this data, these data sets are from optical sensors data. So in the optical sensors, we have issue cloud. So this data is very good, but due to the cloudy scenario or in the rainy days, we can't get the proper signature from Earth. So that's why the new or the another technique comes. It's called radar-based or synthetic aperture radar-based system that can penetrate the cloud. So you can see the same, almost the same time period. Due to the cloud, we can't get anything from the optical data, but we can get some more information from the radar datasets. So these are very basics. With these basics, we can draw the spectral responses. Spectral responses is nothing but response or reflectance at each band. So in an emission, there are several sensors are attached for that particular mission, and based on those various sensors, we can develop different kind of applications. That may be some application on water, maybe some application on vegetation. And when you go deep dive on this, we can understand why and how these things are developed, and what are the real application. And let's say if I want to see the cell structure, then what kind of or what band we should use. If I want to see the water structure or water bodies or water content in the leaf, then which bands could be helpful, or what is the I can say combination of bands we can use. And this is a very simple slide where we can see not only a single field, we can use it in various field of land surface system or land water system or even land air system, monitoring to assessment, and various applications are there. So I'm just starting with a very simple example how we can do the machine learning techniques. As Professor Ghosh mentioned, that we need different kind of data sets, then we need to learn. But in practical, in case of geosciences field or Earth observation field, what kind of data sets we are using? So let's say we can go to the field, we can collect some data. Data means here signature. Signature means here feature. And based on that, we have to understand that what kind of sampling techniques we have to do there, what data is needed for our purpose, and what is our target. All those we need to take from here. So this is one kind of output. If you remember that particular slides from Professor Ghosh, that in machine learning we provide output to figure out the hypothesis. So this is the output first. Let's say we take from here, and in this particular case, we can say, okay, we are trying to see where we can see what crop. Maybe somewhere rice is there, somewhere maize is there. We can collect those information, and this information in remote sensing, all information are geotagged. Geotag means with each information we should have some latitude and longitude information. Then we come to the system, let's say. And in the system, we can play with a single data or single scene, or we can use multiple data sets, or even we can use the time series data. So now we need to combine this number 1 and number 2 using any of our machine learning techniques. Those machine learning techniques based on your application, based on your experience, or based on your choice simply. And when you learn that model, based on those few points, what you can predict the crop type for the whole area. So that's the beauty of the machine learning and this kind of prediction techniques. And it is not always a point-based collection. You can go with the polygon-based collection, and you can test different machine learning techniques, and then you can validate your result, and based on your experience, you can come up the solution. So this is overall the techniques in a nutshell. But I'm going to show a few more examples from where you can see that what are the different fields there you actually people are using, or scientists are using, or researchers are using this kind of techniques. And as we know, we have lots of packages are available, so it is easy to run that things, but we need to understand what we are going to do. So let's say this is an example from Vietnam. This particular area is Yok Don National Park. What the authors have done here, they have taken Sentinel-2 imagery, and from that imagery, we can prepare or we can generate different spectral and texture variable. Let's say we have here generated more than 100 variables. Now, also we went to field. We took the forest or the dBH or width of the particular tree and height of the particular tree, and then we can calculate using those parameter the above ground biomass for a selected points. Now, based on those selected points and based on those 100, let's say the input variables here, we can do the random forest modeling. So you can do some other modeling here, and you can get the spatial distribution of biomass. And people also do one thing, that let's say through some kind of cross validation to understand that which variables are more important and how much variables is required to this is basically optimization of number of variables. So those things or those techniques are available, packages are available. Based on that, we can choose, okay, no, we don't need 150 variables. We can get similar kind of result with, let's say, 11 variables. So those kind of techniques and approaches are there. And based on that, we have generated this particular, in the left side, you can see the particular forest biomass map. And based on that forest biomass map, that random forest best. And then we also, so life is not end here basically, and this is not always a rosy picture. We have other side also. So it has also induced lots of error. So what's the uncertainty on that particular estimation? That also, or then that particular prediction, that also we need to understand. So we have forest biomass map, and also we have the uncertainty map. Based on that, we can consult with the knowledge expert, and we can go again field, and we can again come back and we can change our algorithm. So when we are talking about this machine learning example, we are talking about variety of data from variety of sensors, and in few years we'll have lots of data in remote sensing field also, as we have almost 40 years of archive of data. So handling those things, yes, we have those data sets. Yes, we have packages, various packages, but where to run and how we can manage those very efficiently. So we need some kind of efficient system, and cloud system or cloud platform is there. And when you talk about cloud platform in terms of remotely sensed data analysis or Earth observation data analysis, we are using AWS, Google Cloud Platform, and Microsoft Azure. And based on all this cloud platform, there are different systems or applications has already developed. And these applications are really easy to handle, and here we don't need use the raw data. We can use the ready to use data. We don't need a higher capacity at user end with limited capacity. With a simple internet can solve. And obviously these are very richful system and free for research. So that's a very good part of this. So when you combine machine learning and the cloud platform, it will reduce lots of our time and effort, and we can do more science, we can do more research on the other part, not on only collection of the data and integration of various data sets. So this is one example. Similar, like it is not only biomass, even we can predict the plant functionality type. So this plant functionality type is nothing but a trait of the plant. So here also we can use different kind of remotely sensed data as well as field data, and we can predict the plant functional types. So what kind of forest patches are there along the foot of Himalaya? So that kind of information we can predict based on few sample data, and also we see the accuracy at the producer accuracy and the user accuracy. Earlier I have shown some example from some small area, starting with Vietnam, then our foothills of Himalaya. Now we are talking about the basin level, larger area. Here also, the machine learning and the cloud computing gives us enormous opportunity to understand the basin level phenomena. Let's say in this particular picture or this particular analysis, what we can see almost 40 years of data is there, and based on that we can very easily understand where the flood occurrences are high in last 40 years. And if we going for any kind of policy implementation or other activities, based these data sets are too much helpful. And this is not a 40 years amalgamation. It is you can see the seasonality, you can see the interannual variability using these data sets also. Again, from forest to water, water to crop, and again a large area over South Asia, we can very easily map where what is the crop situation. So if you see in this, even in the Gangetic Plain, the crop situation in a same time not similar. And Bangladesh and West Bengal and part of Bihar behave something different than Punjab or even Uttar Pradesh. So their cropping practices and what is the field condition right now, those we can also map and monitor. Obviously, this is data sets. You can't take it only for a simple geographical location. You can go South Asia to Africa. We can do some kind of analysis for Senegal, let's say. And this is not a single data. You can integrate different kind of data sets from rainfall to vegetation indices and all this. And also you can use this kind of cloud platform to store your data, to create a tool to understand phenomena of like drought or other things. And I am almost at the end of this presentation. So not only land surface, not only water, not only crop, we can also see what is the EOD condition, and over not only a single area. It's all over the globe, South Asia, Asia, Europe, as well as US. So what this particular slide I am showing here, this is not only cloud. Here, what we have done, we have used R as well as cloud platform. So R packages we have used for some analysis. In cloud platform, we have done some other analysis. So yes, it is not that we have to use only one language or only one platform. Based on the availability of the data, based on the availability of the package and our need, we can use different platform, different packages and all this. And again, if I come to the end, at the beginning, I have shown that we have to go to field, use the data, and then we can run the program or algorithm or develop our algorithm. So this is the basic back-end architecture. So what kind of data we are using? It may be shapefile or TIFF file. Those data set may come from through API call or some other assets in the cloud. We can prepare our own algorithm and visualize all those maps and all these things. And even we can take all this output into a separate algorithm, a separate platform where people can use these data sets. As they don't need to understand what is going behind. They can simply take the advantages of this and use those data sets as an output for their research. So this mostly whatever I have shown, those are from my and our joint collaboration with different organizations. We have done all these works majorly, except one or two. But I guess it will be helpful for all of you to understand what kind of applications we can develop. So with that, I would like to thank all of you. And if there is any questions, we'll happy to answer. So let's see if there is any questions in the chat box. Okay. So I don't see any questions in the chat box, but you can mail me or you can mail any of the IEEE executive committee member who are interested to understand the GRSS chapter activities, as well as there's remote sensing based applications on machine learning, all this. And before over to Heshani, I would also like to thank again Professor Ashish Ghosh, Professor Shushmita Ghosh, Dr. Javed Akhtar and Dr. Pratik Dash, as well as Dr. Maheshi and Hassani. So for all of you have supported us, and we all together done a good job. I see that lots of people are still in the participant list. So that's all from my end. Over to Heshani.
One question, Ghosh. Hello.
Yes, please.
Yeah, can you please tell if there is some conference or some publication discount fee if you become a GRSS member?
I'm sorry, could you please tell again?
If you become a GRSS member, so there is a discount in publication?
Discount of publication. I think Professor Shushmita Ghosh can guide us on that.
I didn't get the question properly.
So I guess the participant is asking that if they get this GRSS membership, then is there any kind of concession or any kind of support from GRSS chapter to publish their research work?
No, as such, for journal publication, there is no such. But whenever you are publishing to any conference or something like that, if you are an IEEE member or GRSS member, definitely there is some concession.
Okay, thank you.
And also to participate in any GRSS workshops or conferences, normally GRSS members get benefited through the reduced amount of registration fee.
Okay, thank you, ma'am.
Welcome.
Okay, thank you, Dr. Surajit. And good evening, everyone. I'm Heshani, Chapter Coordinator of IEEE Sri Lanka section. So on behalf of IEEE Sri Lanka section, I would like to thank you all for joining the webinar on machine learning in societal benefits with focus on Earth observation data organized by IEEE Sri Lanka section. So IEEE Sri Lanka section has 10 chapters and 1 subsection under its wing. So we organized this webinar as an initiative to establish our 11th chapter, IEEE GRSS chapter in Sri Lanka section. So first of all, my immense thanks goes to Dr. Ashish Ghosh for sharing his valuable knowledge with the GRSS enthusiasts gathered here today. Thank you very much, Dr. Ashish Ghosh. Then I would like to thank Dr. Jawal Akhtar and Professor Susmita Ghosh for sharing their experience and the insight on the membership benefits of GRSS chapter and your support provided for Sri Lanka section. Thank you very much. We hope to collaborate with you in future events as well. Then my special thanks goes to Dr. Surajit Ghosh, GRSS Ambassador of Sri Lanka section. Thank you very much for taking the initiative and the great efforts you took in making this event a success. And finally, I would like to thank all of you. Without your participation today, this event will not be a success. So today we had a lot of international participants. Thank you for the support extended for Sri Lanka section. And also for the Sri Lanka section members, I would, if you like to join hands with us in establishing the GRSS chapter in Sri Lanka. And also, if you like to become the founder members of the GRSS chapter in Sri Lanka, I would like, I invite you to write to me or Dr. Surajit, GRSS Ambassador for Sri Lanka, and express your interest. We like to have your support in the future events. So thank you very much for joining with us today. And we sincerely expect your support in the future events of GRSS chapter and Sri Lanka section as well. So thank you very much. Have a good night.
Thank you. Thank you all. Good night.
Thank you so much, Surajit, and your colleagues. You are very much enthusiastic for taking up on this GRSS. So it would be really good to work with you. If you need any kind of cooperation from our side, please feel free to drop me a mail, and maybe we can have some kind of joint efforts to enhance the publicity as well as membership in Sri Lanka. So as an ambassador, if you need any cooperation from me, please do not hesitate to write back to me.
Thank you very much,
Thank you.
Dr. Ashish. Thank you.
Thank you, sir.
Okay, thank you then. Bye.
Thank you. Thank you all for joining. And we hope that Sri Lanka chapter will also grow.
Thanks, madam.
And if you need any help from our IEEE Kolkata section, I'm always there. Kolkata
Thank
GRSS
you.
chapter.
Thank you very much, madam.
Thank you.